So, applications of vectors. The famous river question, or the famous airplane in a crosswind question. Spoiler alert, they're the same situation, just in a different context. Here is an example. An observer is standing on the shore of a river which flows to the east. He sees a boat traveling across the river. The boat is pointing due north, but the current is pushing it. So the boat's resultant velocity is 8 meters per second at 65 degrees north of east. Okay. First of all, do you see directions, norths and souths in here, Marcella? Everybody off to the side somewhere draw compass rose. Do you see an angle in degrees? Did I say angle? Components. I'm willing to bet we're going to be going with some components here. You see, I kind of pulled that out of there pretty quickly, but those are kind of some triggers we can do here, and we're going to dulp. So, Marcella, which direction is the river flowing? The question tells us. Read carefully. So I'm going to draw the river like this then. Here's the river. Which way is the river flowing? To the, say it again, east. So I'm going to draw a little arrow pointing east, and I'm going to call that V, and then the C stands for current. If this was an airplane, that would be V crosswind or V wind. Did I give you a current one on your formula? My brain is wondering, did I? Oh yeah, I gave you V engine plus V river equals V shore. I called it V river. Okay, fine. You can keep it a C, but I'll make it an R so it matches the formula sheet. Sorry about that. Then we have a boat. Now the boat is pointing due north. Don't write this down. The boat is pointing this way. But of course, because the river is pushing it to the side, the boat is going to travel in that direction because it's getting pushed downriver. Can you read to me, Marcella, the velocity, magnitude, and direction? And direction? North of what? North of what? East, north of what? East, north of what? So if I'm going to draw that, I guess it's going to be east first. What of east? How many degrees? So bigger than 45. I'm going to eyeball it. I'm going to go about like that, let's say. This angle here is 65 degrees, and it's 8 meters per second at an angle. Did I say angle? Components. I'm not going to deal with that 8, not at an angle. I've left room over here on purpose. I'm going to redraw this small triangle, but bigger to make my life easier. So I'm going to draw it nice and big. It looks like I have an 8. And I guess I'll call this Vx and Vy. Oh, and 65 degrees. Color, 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 color. Cool. Sam, what does A want me to find? V river or V current. How the heck would I do that? What do you mean? Could you elaborate on that? Are you saying that the current shows up in my triangle somewhere? What? Which one is the current? Could you read the 2 letters? One has a V. What? Vx is the current? Oh, if we were flowing north-south, Vy would be the current, but in this, so even though it said how fast is the current, hey, I can find Vx. This is a nice application here. So Vx, opposite, adjacent, or hypotenuse? Sam, my friend. What about 8? If you haven't drawn SOHCAHTOA and you're still having trig trouble, you should write SOHCAHTOA at the top of the page. If you're at the stage where you've got it, you can stop doing that, but I don't know. Which trig function? Of course it is. Cosine of 65 equals adjacent over hypotenuse. So if I tell you the resultant velocity and which way the boat is pointing, we can also figure out the current. Or if I tell you the resultant ground speed and which way the plane is pointing, we can also figure out the wind speed, wind velocity. What'd you get? And again, I hope you're all trying this on your calculator. I hope. You get 3.381? If you got something different, you might have made a typo. I think it's 8 cos 65, is it not? Okay. So 3.38. Sam, units? Cool. Emma, what's B want me to find? How fast the boat's moving across the river? What's B really want me to find? Vy. Or if the river was flowing north-south and I drew a careful vector triangle, I'd end up, that would be the Vx in that case. So don't just memorize, oh, Vy is across the river. It depends how the river, which way the river's going. Vy, opposite adjacent or hypotenuse. Which trig function? Sine, you say? So sine 65 equals Vy over 8. I guess Vy is going to be 8 sine 65. I could have just backspaced and edited. That was lazy of me. And did you get 7.25? Cool. If they ask for a direction east and north, it's kind of implied with the x and the y and my triangles, so I'm not being too fussy. Ooh, I like part C. Grace, what's part C want me to find? Time. Although we could handle it for the river and airplane questions, you can assume no acceleration. We could handle it, but it's overkill. So for airplane crossing a river, let's try that one again. Boat crossing river or airplane in a crosswind. Marcella, assume A is 0. Okay. Can you read to me part C again, Grace? Let's go Dulp. 256. I guess the 256 would go right here, or you could have put it on the other side. Psst. Look up. I would argue that's a vertical distance. Okay? I'm going to argue that's a vertical distance, and that's key to doing this question. I'm going to argue that dy equals 256. The equation I'm going to use here, look up, don't write this down, but just watch Manchand. I'm going to use d equals VIT plus, don't write this down, half AT squared. But Grace, what did we say A was in this question? So this vanishes. And if A is 0, VI is V initial, is V, except that's a vertical. Can you guess which kind of velocity I have to put in this equation? I'll give you a hint. It's not going to be the slanty 8. Are you saying that if I'm using dy, I have to use vy? Yes. If I'm using vertical, I have to plug in vertical values. The biggest mistake kids are going to make in this unit is they're going to put either a horizontal value into a vertical value, or even worse, they're going to use a slanty value, which isn't anything. How would I get the t by itself? So it's going to be 256 divided by 7.25. If I gave this to you as a multiple choice question, would I also have as one of your answers 256 divided by 8? Yes. And would I also have 256 divided by 3.38? Yes. Would I also have one silly one where I'd made up like a 9.8 acceleration or something silly? Yes. There's your 4 wrong answers right there, if you're wondering how I make these up. So it's going to be divided by 7.25. What'd you get? Ooh, I can use my answer button because I have 7.25042. I'm going to use 256 divided by answer button because that's going to give me a couple more sig figs of accuracy. Did you get 35.3080934, or at least 35.3 if you use the, okay. Units. What did we find? What did we find? Look at your very... So, units. And yes, sheepishly, units. Seconds. Yes? Sloppy mistake. What else can we do? Ooh, cool. Huh. Paige, what's D want me to find? I think D wants me to find that distance. I think it wants me to find a horizontal distance. Care to guess what kind of a velocity I'll use in solving this question? Horizontal one. Which one won't I use? Don't be using the 8. Jack, we're not going to use the slanty one. Even, by the way, I made it a nice non-decimal number that, on purpose, just to really tempt you to want, you know, the 8's such a nice number. Why can't I use that? No, it's neither horizontal nor vertical. Paige, I'm going to start off the same way. I'm going to say D equals VIT plus a half AT squared. But what's 8? 0. So I'm going to argue, since they gave me, or they want me to find a DX, I'm going to use a VX. Well, I've scrolled down. What was VX, Paige? Oh, I don't know time. Or do I? Is the time to go across the river the same amount of time as I'll drift down the river? In other words, can I use my answer from part C here? Yeah? And is time a scalar, so it doesn't matter whether I use it in a horizontal or in a vertical equation? Ah, so I can use, I can't remember, 35.3, although I'm going to use my answer button. So what was VX? 3.38 times answer button. How far down river will we drift? Almost 120 meters, 119 meters downriver. And then I guess we'll have to walk back along the shore to get directly across from where we started from. Matt, what's the boat's engine velocity? Too slow. Matt, what's the boat's engine velocity? No, too slow. Percy, what's the boat's engine velocity? No, you're too slow. When I'm doing that, what I'm really saying is you already know the answer if you're clever, and you should be able to just call it out. What is the boat's engine velocity? What? That must be what that 7.25, it's not the 8 because that's the combination, but what's pushing it across, that must be the engine velocity. The engine is not just Vy, it must be V engine, 7.25 meters per second. That's how fast the motor is capable of pushing this boat through still water. So now let's put this all together. Jack, don't write this down. I'm really going to muck up my diagram. Let's suppose you're leaving here and you'd like to end up here, but you know the boat is going to push you downriver. I don't know if any of you have ever motored across a river. What you actually do is you point the boat that way. And it looks a little bit funny because the boat is pointing in this direction and going straight across. It's kind of crab walking across. But that's what you do if you want to end up straight across. You folks are too young to remember the Albion Ferry, but the Albion Ferry that used to run on the other end of town before they built the Golden Ears Bridge had to do that all the time. You would look at it from the shore and you would say, oh, it's going straight across, but it's pointing into the current. So, F, I like F. Suppose you want the boat to land directly across from its starting point. A, what direction should you point the boat in order for it to travel in a straight line due north? And B, what will its resultant vertical velocity be? Now, a lot of people might say, wouldn't you just point at 65 degrees? No. 65 degrees did not give us a straight path due north. 65 degrees gave us downriver. But I can tell you what it's going to look like. So I'm going to dulp. Here's the river. I'm definitely pointing it that way. This is which way I'm going to point the engine. Mansion, what? Which way is the current going to push us? And I'm still using the idea that V engine plus V river is what gives us our ground velocity. So I want to add the engine and the river together. How would I add those two vectors together? Draw them. Draw them. Everybody, draw them. Put your pencils down, look up. So the river, don't write this down, looks like that. Or, maybe it looks like, wait. I know when to stop drawing my vector because I know the direction of the resultant. Which way did this question tell me the resultant is going to be? If I want it to land directly across from where I started, what direction do I want these two to add together? So watch, look up. Tell me when to stop drawing the current. Has to be exactly that big because that's the only way when I go from the tail of the first to the tip of the second that I get the ground velocity. This is a little weird because you're used to it always being the hypotenuse, not always the hypotenuse of a triangle. Here it turns out they gave me the hypotenuse with the engine. But I know what my triangle has to look like because they told me they want the resultant due north. So I know don't draw the current that long and don't draw the current that short. That's the only possible triangle that I can draw. Ooh, I know what the engine is, by the way. It was 7.25. And what was the river? 3 point what? 3.38? Okay. Where am I going to put the theta? Top left or bottom right? Where my resultant is coming from. Color. V river, opposite, adjacent, or hypotenuse. V engine. To find angle theta, which trig function am I going to use? Because A wants the direction. That's the physics speak for saying find the theta, the what of what, north of south, east of west, what of what. Ooh, I probably better draw a compass rose because I've scrolled down. Which trig function? Sine. Every up till now, every time when you've been finding theta, you may have noticed it's been tangent. Won't always be. If I give you a more complicated question, Harsh, it won't be. Specifically, if I give you a question where, I gave you the hypotenuse. So sine theta equals 3.38 over 7.25. What's the direction I would need to point this boat? How many degrees, first of all? How do you find that? Shift sign? Yes? Armand, what'd you get for theta? Oh, he's typing. Sorry? It can't be 0.7 degrees. 27. Point. Anybody else? Because it's math. 27.8. North of south, east of west, what of what? That's west of north. Now, Matt, I did this as boat going across the river, where this was done before GPS. If you were an airline pilot and you knew which way the wind was blowing and you knew where you wanted to end up, you would figure out, how do I point my plane into the wind so that I end up where I want to go? Instead of ending up way past where I want to go and having to fly into the wind, having to walk back along the shore. That's a bad way of doing it. Is that a hand up, Harsh, or just a stretch? Okay, so there's my direction. What's B want me to find? Yeah? I don't know. I don't know. Let's see. Is that not west of north? Start out going north and then point your boat west, and that will guarantee that the resultant is due north. And by the way, you're also seeing it's really easy to trip on your brain here if you're not careful. Don't kid yourself. This is not easy stuff. I mean, it's Math 10, SOHCAHTOA, and Pythagoras, but it's a lot of deep applications. By the way, Matt, what's B want me to find? Wants me to find this magnitude. Oh, and then the direction I can already tell you, north. How can I find this magnitude? Well, I can still use Pythagoras, but now I'm not finding a hypotenuse. So that squared is going to be 7.25 squared minus 3.38 square root. And I'll write that in the notes just to remind you, we're not finding a hypotenuse this time. Don't get casual. You've really got to pay attention here. Oh, square root, Mr. Duke. And I get 6.41. .41 meters per second at north. Now, this will take a little longer to get across the river. You could actually solve for time if you were bored. It would be 256 divided by 6.41. But you're not going to have to walk all the way back. So this is what you do when you're in a crosswind or in a current. You point your boat or your airplane into the wind or into the current, and you figure out which way do I want to point it to end up in the direction that I want. Okay? So here's your hint. If they give you a vertical distance, use Vy. If they give you a horizontal distance, use Vx. We'll pick up with example 2 next class. It's another river question. Then we'll do an airplane and a crosswind. And then you'll have lots of time to work on the homework. Did I say, Emily, that you're going to get pretty good at trig? You may be noticing that every question you're doing Pythagoras and or SOHCAHTOA. You'll get pretty good at which by the way is a handy skill. How many did pre-calc 12 already? Okay, so sorry, but had you had pre-calc either this quarter or next quarter, oh, you'd be the trig in your sleep almost. I would have beaten it into you, and so yay. So we'll pause here. Your homework is work on the stuff from beforehand. If you finished the lesson 3, then you're good.